Okay, so ito na tayo, no? Simple stress. Okay. So simple stress and strain, tuloy pa rin tayo sa nampisa natin. So, yung last session, we started about simple stress, ano? And mayroon din tayong, wala pang stress. Simple stress pa lang. So, the area is just, the stress is just equal to force over area, ano? So, kadalasan sa mga stresses na nakakuha natin sa sa steel truss or mga compressive stress members, yun yung mga simple stress. May bearing stress din, contact between two bodies, halimbawa sa mga lateral surface, mga lateral load, example sa retaining wall, or the soil bearing capacity, or the resistance between the soil and the structure, the footing. So may soil bearing capacity siya. So contact between two bodies, may bearing stress na di-develop. So ito namang thin-walled cylinder, isa rin sa mga topic dito na about to compute yung sa stress ng thin wall. Yung thin wall kasi, yung cylinder kasi na to, pressurized siya, ano? Gaya sa mga gas tank, may pressure siya kaya since may pressure inside, merong stress na nade-develop dito sa wall. Okay? So kung titingnan natin tong and we are going to analyze this longitudinal section or tangential of that tank, meron dito F na caused by the internal pressure. Tsaka may force din that causes pressure dito sa thin wall. So, kung magsasum up tayo ng forces vertical, going up, at saka going down, at saka going up, ito tayo. No? So, going down, itong F is equal to going up na dalawang P. 1 and 2. So, alam naman natin na yung F na to, this is because of the internal pressure at saka itong area na to. Alin itong area ito, ano? Itong, ano, kung titingnan natin sa taas, ito yan. Ito yung area na yan. So, this is diameter at saka ito naman yung L. Yung thickness, andito eh. Okay? Ito yung thickness ng wall. Okay. So, 2P is equal to F na internal pressure at saka yung area. Internal pressure, kilopascal yan. So, gaya sa mga pressure tank, ano, na nagsusupply ng water, so pressurized siya. Ano? Yung pressure, naka-compress, ano, or gaya sa mga gas tank, compressed yung inside, may inside pressure na nako-compress yung stress sa loob. So, area is, as I said, D times length. So, we can come up to compute with P. Itong P, ito yung force P or the tension force P at the wall. Now, pagka kinumpute na natin yung stress dito sa wall na to, sa wall, ito lang yung wall, is just equal to P or the force over area. Ang P, ito, internal pressure, diameter, length, okay, over 2. At saka yung area niya, area nitong thickness or area nitong wall is just equal to T at saka L. So this is T at saka L. So makakancel lang natin yung L, matitira itong PD over 2T. Okay? Pagka yung cut is longitudinal, yung isa na pala sinasabi na tangential, okay, ibig sabihin, ito yung tangke, pahaba, no? or maybe ganon. Ito ang cut dito. Yung isa, ganyan. So, this is a circular tank. So, ang pressure dito sa tank, ito ano, P, pero paikot siya. Hindi mo masasabing 2P. Ano? It is just only 1P. Nilagay ko lang dito para ibig sabihin that the pressure is the same along the entire thickness nito, ano. So, what is the value of P? So, that is just, itong P is just equal to F, ano? Yung F is equal to internal pressure, yung small p, at saka tong area ng circle inside, itong area, andito naman yung pressure, ano? Sa loob nito. So, ang area nito is pi over 4 over d squared. Now, paano mo naman makompute yung P? Pagka kinompute mo yung stress na P over area, ano yung area nito? Ito pagka kinat ko ito dito, no? Kinat ko tapos hiniwalay ko, magiging ganito to eh. Ano? Itong pi d or ganun, ano? Pi d is just this circumference. Ibig sabihin, ito yung circumference, ano? Paikot. Pagka minultiply mo sa thickness, magiging area na. Bali, ito na yung magiging, ito yung wall niya, no? Na kinat natin. Tapos that becomes a rectangular in section. Rectangular section. Okay. Okay. So, P is equal to area. So, pag sinubstitute na natin, P, andito naman, no? Okay? Pi over 4d squared times P, itong small p, internal pressure, at saka yung area, itong pi d times t. Makakancel itong pi, makakancel din yung isang d. Dapat big D rin to, ano, squared, gano'n. So, makakancel isang d. Okay? So, P d over 40. In other words, madali siya. Maalala. Pagka longitudinal, ibig sabihin yung section mo is circular, gano'n, ano. Pagka circular section, 4 dito ang denominator, 40. The same numerator, PD. Pero pagka ganito na rectangular yung section, ano, ito rectangular section, PD over 2T. Okay? So, limbawa ito, there is a cylindrical pressure vessel. It's fabricated from a steel plates which have a thickness of 20 millimeter. The diameter of the pressure vessel is 500 millimeter. So, parang kwanto, tangential, ano? Parang ganito to. Ano? Parang ganito yan. Ang diameter is equal to 500. And then the length is equal to 3 meters or 3,000 millimeter. And then thickness, ito, 20 millimeters. Dito may na maximum internal pressure. So, ano yung internal pressure dito? Okay? So, actually, pwede na natin gamitin dito yung stress na PD, okay, over 2T pagka ganito. Okay? Makukompute na natin tong internal pressure. Kahit i-try nyo, ano? P is equal to 11.2. Sinubukan ko na using this formula, P here is 11.2. Ano, kasi ganito lang din dito eh. F, asan yung F? Okay, ito. Yung gaya sa derivation natin kanina. F is equal to internal pressure, diameter, and then length. Okay? And then substitute diameter, length. So, makompute natin in terms of internal pressure. 2T, ito na yung T dito. Yung tension in the wall. Ano? T is equal to F. So, you can compute here T is equal to 750,000 times P in Newton. P is internal pressure. Substitute natin dito as the force and then area. I'll come up with this one. But then, as I told you, we can use this one. Ano? Right away, we can use this one. Dapat lang kasi, for you to use this one, is for you to figure out that your thin wall cylinder is in this case. Okay? Dapat ganito yung case niya. How about this one? A water tank is 8 meters in diameter and 12 meter in height. So, alam natin 'di ba sa hydraulics? Okay. Pagka meron tayong height na, let's say, you have 12 meters, okay? Sa water, ano? If you have here the water level, okay? We can compute the maximum pressure at the bottom, ano? Siguro na-experience natin, ano, pagka nasa ocean ka, no? Nagsiswimming, as you go deeper, may the pressure in your ears increases, ano? That is because of this concept, no? That the pressure here is varying from zero. Pag nasa taas ka, okay lang, walang pressure sa kuwan. Ano? Walang pressure sa tenga. As you go deeper, tumataas yung pressure. Ano? Tumataas ang pressure. Because it varies directly proportional to the height. Ano? So, ganun lang to. The unit weight of the water and then the height. Okay. Mas makalati lang ang pressure dito compared dito kung nasa gitna ka. So, the question is, if the tank is to be complete filled siya, no? That 12 meters in height. Determine the minimum thickness of the tank. Plating, if the stress tank plating, ibig sabihin yung stress doon sa wall, sa plate o tank plating. Determine the minimum thickness of the tank plating. Itong T, ang tinatanong, what is this T? If the stress is limited to 40 megapascal. Ibig sabihin, ang stress dito is limited to 40 megapascal or Newton millimeter squared. Okay? So, andito na yung formula na yan. Yung sinasabi. W, alam naman natin is 9.81 kilonewton per cubic meter or Newton 9,810 pagka Newton. Pag 9.81 kilonewton cubic meter. Multiply mo ng height na meter, magiging Pascal siya. Ang pressure is in Pascal, Newton meter squared. Pag minultiply mo siya ng another 8 meter, antong 8 meter diameter? Kasi andito yung pressure eh. Parang pag ganun dyan. Ano? Andyan yung pressure. Ano? Parang ganun. Okay? May WH ka dito. I-multiply mo dito ng diameter. Okay? Diameter. And then you have the thickness, yung taas na T, nag-consider lang siya dito ng 1 millimeter. Ano? Board exam type to, ito yung approach niya doon. So, ito ang kukuha na natin, susundin natin. Actually, kung tignan mo talaga ang kuha niya, yung total na thickness 12 meter ang gagamitin mo. The tank is determine the minimum thickness of the tank plating. So, ito, consider lang niya yung pang 1 millimeter strip. Okay? So once you did this one, may F tayo. The same with the formula kanina na F is equal to 2P. Ano? Makompute natin yung P. Okay. And then, substituting it here, S, or the stress in the wall, is 40. Ito ang sasabi ko, 40. This one is in terms of Newton millimeter squared. And then, you have your P. Ito, ano? This is P na nakompute natin galing dito. And then, area is just ito. Ito yung area. Thickness times, ito. Thickness times ito. Thickness, dito, 1 millimeter ito, no? Thickness, ito yung thickness, ano? Ng thickness ng plate o thickness ng tank. Thickness times 1 millimeter. 1 millimeter at saka thickness. Kasi itong stress na to ng plate. No? Itong stress kanina na ito, na 8 times 0.001, ito yung stress doon sa loob ng tank due to the internal pressure. Ang internal pressure dito is caused by the water. Okay? Okay lang? Sir Robert?
Okay lang po. Okay lang.
Sige, continue ko. So, simple strain tayo. So, familiar naman sa atin yung stress na strain diagram, ano? Ito yung halimbawa, pagka may, sabi na natin, this one represents such a graph for structural steel. So, structural steel tayo, no? So, sa structural steel, subjected to a tension test, ano? So, let's say, pag maglagay ka dito ng, halimbawa, 100 kilonewton, so obviously, meron din dito possible na elongation pa. Kuwan lang natin, exaggerate lang natin. So, proportion siya, ano? Pag mag-add ka dito ng P to that area, may area nito is constant naman, ano? Isang specimen lang naman siya. Steel bar, sabihin natin. Isang area lang siya. Pag mag-apply ka ng load, meron din dito changes ng strain. Ang strain has something to do with the change, bawa ito yung original length, ito yung changes, ano? Ito yung D at saka ito yung L. Pag mag-apply ka ng load, ito yung ratio na ito, strain na to. Ito naman stress. Halimbawa, may stress ka dito, representing a certain load. Halimbawa, 100 Newton to a certain area. Ano? Meron din dito corresponding value ng strain, which is something to do with that D. Ano? Itong D over L. Ito, mag-increase ito. Ano? When the load increases. Kung ano ba, 100, maging 200 na dito. Obviously, ito, mag-increase din, pupunta din dito. Halimbawa, dito rin pa rin, no? Pupunta pa rin dito. At that certain line, proportion siya, kaya tinatawag proportional limit. But after the proportional limit, yun na yung, ano, nasa elastic range na up to the point na kaya pa niya bumalik sa original length niya. Pero after that elastic limit, ayun na yung point na hindi na siya bumabalik to its original length. Ano? May na siya. Humahaba na. Up until na umabot, it reaches that yield point, yung breaking point na talaga. Sa design natin, ito yung after that one is, ito yung working design natin sa yield point siya. After that one, yun yung ultimate strength na, yung pinakamataas na talaga na allowable pa siya for a design. Okay? Pero after this one, yan na yung magko-collapse na talaga. Ito naman, makikita to sa laboratory. Yung pagkagawa ka ng graph, ito typical to para sa steel. Okay? Sa steel. Sa concrete, medyo mababa siya. Kaya nga ang concrete, ang modulus of elasticity niya is 200 gigapascal. Okay? Ang concrete, mas mababa siya. Mas lalo ang timber. Nandito lang yung timber. No? Modulus of elasticity, okay, is just equal to, it's the ratio of stress and strain. Kaya nga, meron tayo itong formula na P over L at saka ito naman, ito strain pala to, strain. Okay? P over area, ito naman D over L. Itong D, ito na yung deformation. Kaya may formula tayo na deformation pagka nag-cross multiply tayo. Okay? Itong maging formula natin. PL over area times E. Ito yung modulus of elasticity. Itong kadalasan na ginagamit natin na formula dito sa strain. Kadalasan sa mga related type na mga questions, mga problems na board exam type is to compute for the elongation of the material. Ano? So ito is galing dito. Kasi pag ito, magiging kwanto. Itong L, punta sa taas, PL, over dA. Okay? We cross multiply, we can compute D. Or D, lagay natin doon. Yung E naman, pupunta sa baba. Kaya ito na yung formula. Okay? So, ito yan, sinasabi ko. Ito yung formula natin. Natatandaan sa, this is according to Hooke's law, that the slope of the straight line portion of the stress strain diagram is called the modulus of elasticity. Asan yung straight line na yan? Ito na yan. This is straight line up to the point of the proportional limit. Kasi proportion siya talaga. Na-depende lang yung changes ng deformation with that of the changes in load. But beyond that, after the proportional limit, nagbabago na siya. Nagbago na ang curve. So for example, we have here steel rod. May isang rod siya na has a cross-sectional area of 300 square millimeters. Pag kinat natin to dito, sabi natin rectangle or circular, sa rectangle or circular, ang area niya is 300 square millimeters. Okay? And the length is 150. Suspended vertically, ibig sabihin, naka-fix siya dito. Okay? But this steel has a mass of 708 or 7,850 kilogram per cubic meter. Alam naman natin na modulus of elasticity is 200 times 10 to the cube megapascal. Okay? So, what causes this one to deform or to elongate? First is due to its weight. Anong weight niya? Ito is 7,850 kilogram per cubic meter, unit weight. Ano? But, aside from that, may elongation due to this force. Ito na yung P. Dito applicable yung deformation is equal to PLAE. P is given 20 or 20,000 Newton. Take note, dapat naka-Newton tayo dito. L is millimeter. Okay? Area is millimeter squared as well. And then, modulus of elasticity, Newton, millimeter squared. Para pag mag-cancel out lahat, ang value ng deformation is millimeter. Okay? Ganun lang. Pero dito, what formula? Okay? Ito na yan. Ano? Kailangan lang memorize itong formula. What is this? Okay? Ito yung W na 7850. G. Actually, this is a conversion from kilogram. Naka-kilogram siya, cubic meter, no? Itong kilogram, pag minultiply mo ng gravitational force na 9.81 meter per second squared, magiging Newton yan, ano? Kaya nga, 1 kilogram is approximately equal to, sabihin na natin 10, magiging 10 Newton. 1 kilogram is 10 Newtons, di ba? In-approximate na lang na 9.82. Sa akin, mas madali din na gano'n na lang, ano? 10 approximation. So, magiging ito, pag minultiply mo 7,850 by 9.81, magiging Newton per cubic meter. Okay? Take note, na yung W mo dito, unit weight yan, ano? Or dapat naka-kilogram per cubic meter. Kasi pag naka-Newton yan, huwag ka na mag-convert. L, ito naman, 50 meter. Modulus of elasticity, given naman. Okay? Kaya yun, ano? Ito. Nilagay ko kompleto yung unit para makita. Ito Newton to dito, ano? Magiging Newton to Newton, okay, cubic meter. Okay. Ito magka-cancel out to, ano? Meter matitira. Kaya mag-convert ka na 1 meter is equal to 1,000 millimeter. Okay? Kaya 1,000 ito dito. Ito Newton millimeter square naman. Kasi Newton, ganun yan, sa taas, Newton millimeter. 1,000 millimeter is 1 meter. Siyempre, pag tinaas mo, pupunta yan dito sa taas. Okay? Kaya nag-multiply dito ng 1,000. So, in other words, our answer is 4.33 millimeter is the elongation caused by the weight itself. Ano? Weight pa lang, wala pa yung force. Ngayon, nag-apply pa ng 20 kilonewton, mas lalaki siya. Ito na yung PLAE. Ano? PLAE. Okay? Okay? Ano yung P? 20. So, that's kilonewton. Multiply mo ng 1,000 para maging Newton. 150 meter, multiply mo ng 1,000 para maging millimeter. 300 area, ano? Ito, 300 square millimeter na to. Walang problema. 200, ano to? 200 gigapascal, ano? 200 gigapascal or gigapascal? 200 times 10 to the 3 megapascal, okay? Okay. So, 200 times 10 to the 3 megapascal or Newton millimeter squared. Parang nagsobra yata ako ng 0 dito. Dapat 6 lang. Okay? Tama ba? 200 Habang 200,000, 200 gigapascal. Okay, wait. 200 gigapascal nga. Or 200,000 megapascal. Ang megapascal kasi is Newton millimeter squared na eh. So, check na lang natin. Check mo. Ito dapat to the power of 3 na lang yan. To the power of 3. Okay? Check na lang. Kasi 200,000 megapascal. Yung megapascal is equal to Newton millimeter squared na. So, kung Newton millimeter squared na, okay, ma-answer lahat natin sa millimeter. Check natin kung 50 nga siya. 20 exponent 3 times 150 exponent 3 divide 300 divide 200 exponent 3. O yun, 50. So itong 9, eksakto no? 3 lang, ano? Ito, 3 lang.
3 lang. Okay.
Nagkakakuha lang sa pagsulat. So tama yung sagot na 50. Okay?
Sige po.
So, naka-download na to kung sakali. Tingnan mo na lang doon tapos correct mo na lang sa diniscuss natin. Anyways, maganda naman pagkatapos kung may time ka, solve mo rin. Madali mag-1. Halimbawa ito naman, the rigid bars, okay, shown in the figure are separated by roller at C. Ito, may roller siya dito. Ibig sabihin, pwede siya matanggal, ano? And then, pinned at A, pin siya. Pagka na-pin lang, pwede siya mag-rotate. Free rotation siya, no? Hindi siya fixed. Also at D. A steel rod at B, ito naman, help support the load of 50 kilonewton. Okay? Ito yung 50 kilonewton na load. So ito obviously tension to dito. Compute the vertical displacement of the roller at C. So anong displacement dito? No? Vertical displacement. So mangyari yan, ganun, ano? So ito obviously, because of this 50 kilonewton, meron ditong elongation. Okay? Elongation at B. Ito naman itong vertical movement at C. So dito pala magkakaroon tayo ng triangle. Okay? Magkakaroon tayo dito ng VC. Ratio of VC is to 4.5. And then you have, ito naman na elongation at V is to 3 meters. Ang tanong is to compute for VC. Pagka ma-compute na natin to, ma-compute na yung VC natin. But before we can compute this elongation, dapat ma-compute muna natin dito yung T. But for us to compute for T, ito, due to this 50, meron to dito may apply, ano? Okay? Na load. So, parang ganito lang, ano? This one is 50 kilonewton. 50. This is D. And this is C. Okay. Since nasa mid-span naman siya, obviously, di na tayo kailangan mag-compute. Kasi kung 50 yan, nasa gitna, kalahati lang to. This is 25 and this is also 25. Alright? Kalahati lang siya. So, 25 lang din dito. So, we can compute this T. Pag mag-tick moment tayo dito sa A, bahala ka na kung saan ang ikot. All clockwise is equal to counterclockwise direction. Okay? So, clockwise dito, this one, Okay. So, this one is 25 also. 25 din. So, you have itong T, paikot papunta dito tayo nagpaikot, is times 3 meters, is equal to itong 25 na paikot papunta naman dito. 25 times 4.5. 4.5 yung distance mula dito hanggang dito is 4.5. So, makakompute natin dito yung T na 37.5. Pag meron na tayo ng T, makompute natin tong elongation at B. Kasi nga, sa formula natin na PL, very famous tong formula eh. This one is our T. Okay? So, we can substitute it here. Dapat, consistent tayo sa unit lang. So, this one is in Newton already. 37.5 multiplied by 1,000 is 27,500 Newton. And then you have L is 3,000. Andito naman, no? And then area, which is 300 square millimeters. And then modulus of elasticity na 200. Mako-compute na natin yung elongation at B. Dahil na nga dito sa sinabi ko kanina na ratio ang proportion natin sa triangle, so we can have VB as, or elongation at B is equal to 1.875. Pag substitute natin, we can compute na yung VC. Okay, by ratio proportion. VC or YC, ano? Okay. Vertical movement or sabi na Y or VC. Okay. Then we can compute YC. Okay, for Joy, umpisa pa lang, ilang ko pa lang kami. Tatlong example. You can just go back to the recording. Okay, so next example. Okay. Wait. Wait lang for a while. Okay, so next problem, we have the rigid bar, AB, this AB being attached at this support by these vertical rods. Here, this is a steel. The modulus of elasticity is 200 gigapascal, that's steel. And then the other one, also, another material, has to support 50 kilonewton. Okay, at this location, 2 meters from A. Now, we are asked to determine the vertical movement, its vertical movement, meaning the vertical movement of this here, this P. So if we can determine the movement here, or the elongation here, and this one is for steel, and then also here. Okay, so which do you think will have a bigger value of elongation? Possibly here or here. Here, okay, mas mababa yung modulus of elasticity. Pwede papunta dito, ano? We will see. Okay, if this one, we can check if this is really the value of the elongation. Okay, so but first we have to compute what is this P, let's say for steel, and then the other one, I think this one is copper or aluminum. P, let's say A. Okay, if we take moment at A, makompute natin yung PS at saka PA. Okay, so we take moment at A. Okay, take moment dito, 50 times 2 papunta dito is equal to PA times 5. Therefore, we can compute PA. Pagka may PA na 20 kilonewton and this is 50, in other words, PS is 30 kilonewton. Okay? Now, we can compute the elongation at the steel rod. By this formula, PS is 30, L is 3 meter or 3,000 millimeter, area is 3,000 square millimeters, modulus of elasticity is 200,000 megapascal or Newton millimeter squared. So we can have 1.5. Ibig sabihin dito, 1.5, anong value? Now we can check millimeter, okay? Now we can check what is the value of that for aluminum. Sa aluminum, 2.286. Okay? So, ibig sabihin, tama yung assumption natin kanina na this one is for the steel, this one is for the aluminum. This is only 1.5. Okay? So, this will be the final location of this rigid bar. Kung hindi siya rigid, hindi mag-elongate ng ganun, ano? Kung hindi siya rigid, dapat gumanon lang siya, ano? So since this one is rigid, so the question is to compute for the vertical movement here. Ano ba tong distance na to? Okay? Let's say V. Okay? This one is 1.5, ano? The same with that one. This one, since this up to here is 2.286, na-compute na natin. Okay. So this one is 2.286 minus 1.5. It's around 0.7 something. Okay. 0.786. So we have this triangle, ano? This is small triangle, okay, is similar to this big triangle. Mula din dito, papunta dito. So we can have ratio proportion. Okay. 0.786 is to 5. And then YP minus YS, or V na lang. Sabihin natin V, ito. YP is, ito siya. V na lang. Is to 2. Ano? Pwede V din is to 2. Ang YP niya dito is ito, ano? Itong YP. Ano? Itong YP. Ito naman YP ang tinatanong natin. Location, movement coming from here. YP minus YS or 1.5. YP minus 1.5 is to 2. Pwede rin, V, lagay natin dito, V plus 1.5. YP, okay? YP minus 1.5. YP, this one is 1.5, is to 2. Okay. YP, that is the total vertical movement, or total vertical distance starting from here, no? Or here. Nag-move pa siya, papunta ron. May 1.5 dito na kuwan. Mula dito, may 1.5 na elongation sa steel. 2.86 naman na elongation sa aluminum. Aluminum, and this one is steel. Okay. So we can have YP. Okay. Computed na kanina. So it's 1.5. Ito naman 0.786. So we can have YP is equal to 1.814. Which is true, ano? Kasi dito, 1.5, dito 1.814, dito naman 2.286. Ibig sabihin, ganun yung kwan. Pag ganun. Okay. Andito yung original na location ng kwan, ng original location of this block. So andito yung 1.5, andito naman yung mula dito na 1.814 na vertical movement natin na vertical movement na tinatanong. Andito yung P na 50 kilonewton. Okay? May tanong ba? Okay lang? I think it's clear. Okay. How about ito? So here you have a steel bar 50 millimeter in diameter and 2 meter long. Ito, 2 meter yung haba. Ang diameter, ito, 0.5. Sa pag-drawing lang to, hindi ko na-edit. But this one is 50 millimeter. Okay. This one is 60 millimeter. Bakit? Kasi ang thickness is 5 millimeter. Kung 5 ito, another 5 here, plus mula dito is 50, so that becomes 60 lahat. Now, compute the load that will compress. Ano yung load na will compress this combined bar? Ano? Binabalot ng cast iron itong steel that will have a compression. Ano? Length of 2 millimeters. Ito 2 millimeters to. Ano? Kino-compress siya until 2 millimeters. Ibig sabihin, the steel will have a compression or opposite ng elongation, ano? Na 2 millimeters. Ganun din yung cast iron, 2 millimeters din. Pero yung total load niya is total ng compression P for steel and then P for cast iron. So kaya meron dito. Ano? Ito yung total P niya. Equivalent to that particular load. So, let us compute the area. Ano ng area ng steel? It is just pi over 4 d squared. Ang d is 50 millimeter. Ito naman, pi over 4, okay, diameter ng malaki, okay, and then deducted by diameter of this steel. So, ibig sabihin, this one is just only for the cast iron. So, this is 275 pi. So, deformation is 2 millimeters. 1 millimeter ba? 1 millimeter pala, no? Okay, 1 millimeter, hindi 2 millimeters. It's 1, okay? 2 meters yung length. Length ng bar. So, 1 millimeter ang deformation that will be caused by the P for steel or load for the steel. So, mayroon siyang equivalent load that will cause deformation of 1 millimeter in the steel section. Now, 196.35 kilonewton or 196,030 newton. And similarly, for cast iron, may 43,000. Mas maliit siya. Ano? So, pagka sinama mo siyang dalawa, you will get the total load P. Okay? Dali lang, ano? Dali lang. Okay, let's continue. How about this one? A rigid block. Okay? Rigid pa rin, ano? Kasi nga, kung hindi siya rigid, hindi naman siya mag-deform dito or mag-elongate or mag-shorten or compress. Supported by 3 symmetrically spaced rods. Symmetrical siya. Each copper rod has an area of 900, and then the allowable stress is 70, modulus of elasticity of copper is 120. The steel rod has an area, ito, 1,200, modulus of elasticity is 200, and then the stress is 140. So the location, hindi ba nasabi? Okay. But the location should be like this, ano? Dito copper, 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 steel. Kasi kung halimbawa, if this is copper, copper, steel, ano mangyayari kung copper, copper, steel? So most likely, kasi nga, the steel has a bigger amount of modulus of elasticity. Ibig sabihin, mas matibay siya. Ano? Kaya niya, mas malaking capacity niya ng tension or compression. So gaganon yung magiging kuan niya. Deformation. Ano? Ang compression dito, mas mataas. Okay? Since na rigid din naman to. Gaganon. Pero pagka copper, steel sa gitna, copper sa gilid, uniform yung movement niya, no? Dito yung magiging final na location niya. Considering na exaggerate lang natin ang displacement, ano? Okay? So ganyan ang magiging orientation ng final location ng bar. Okay? So, how are we going to come up with the equation? Madami tayong pwedeng ma-formulate na equation, ano? Para anong question? Para ma-determine natin yung mass. Okay? Okay? So, we can come up an equation na equal siya. Ano? So, PS, elongation at S, or the steel, at saka elongation ng copper, is the same. Ano? Equal siya. Ano? Kasi nga, symmetrical siya, nasa gitna yung steel, equal yung magiging elongation niya dito. Okay? So, we can have this formula. Lagay lang dito stress ng steel, stress naman ng copper. It's the same as P over A, ano? Stress ng steel is P over A. So, is na lang ilagay. Okay? So, we can come up with this relationship, ano? We can come up with this relationship that the stress of the steel is equal to 1.111 of the stress of the copper. Okay? So, how are you going to compute your P? Kasi ang W dito is actually W is just equal to PS plus 2PC. Ano? Tinatanong sa atin is to compute for M. M ba? Ayan. M. Pag makompute natin PS and PC, we can easily get the M or W. Okay? So, we can have this assumption. Okay? If SC is 70 megapascal, SC, copper. Kung substitute natin ng 70 dito sa SC, 70 times 1.11, okay, dito, lagay natin SS. If we try that S is equal to 70 megapascal, 1.11 times 70, ang magiging sagot niyan is 77.778, which is less than 140. Ano yung 140 na to? Okay. This is the, ito magiging stress ng steel. 140, this is the allowable stress ng steel. Ibig sabihin, kung ang mag-yield ang sa stress ng copper, which is obviously, yun talaga mag-yield kasi mas mababa yung modulus of elasticity niya, ang corresponding na stress doon sa steel is 140 lang. Ibig sabihin, pag bumaba siya dito, no? There is a vertical movement here. The stress of the copper would reach a maximum, sabihin natin 70 megapascal, nag-yield talaga siya, na maximize. Pero the equivalent stress para sa steel is only 77.778, which is safe. Kasi as long as it's lesser than 140, safe pa rin siya. Ano? Hindi siya magko-collapse. Whereas, kung halimbawa, i-try natin, halimbawa is S. Ano? From here, i-try natin. Substitute. If, sabihin natin is shear, stress of the steel is 140. Compute natin kung anong mangyayari. 140 is equal to 1.111 SC. What is the corresponding value of SC? Compute ko, ha? 140 divide 1.111 is 126. Ano? 126. Ano ang allowable na stress ng copper? Dapat 70 lang. This is greater than 70. Pagka mag-yield ang steel na umabot ng 140 megapascal, ang corresponding stress ng copper is 126. Ibig sabihin, collapse na siya. Ano, magko-collapse na kasi ang allowable lang na stress ng copper is 70. Collapse na siya. So, kung gagamit tayo ng stress for us to get, kung gagamit tayo ng value for us to get the safe value of your M, gagamitin natin itong SC na 70. Kasi, if we use SC is equal to 70, it will just give us a yielding stress for steel to just 77.78. And it's less than 140 and it is safe. Ibig sabihin, ito ang choice natin na gagamitin. Hindi ito. Kasi pag ito, hindi safe value yung makukompute natin ng PS at saka PC. Okay? So if you are going to use that one, andito na yung sinasabi ko kaninang formula. So we can have ASSC. Okay? Meron na tayong value ng AS. May SS tayo. Ang SS is 77.778. Okay? Ayan na, no? 2 AC, area ng copper is 900. Tapos, stress ng copper is 70. Then, converting W to get the kilograms, multiply mo lang ng 9.81 or mg, makakompute na natin yung mass. Kasi pagka mass, kilogram yun. Ano? Pagka weight, Newton or kilonewton. Okay? Okay lang ba? Walang question? Okay, good. Okay, you try the activity. Try niyo yung activity. Madali lang to. Kuwan lang naman. Similar lang din. Try niyo lang. Siguro mga 5 minutes lang to. Kuwan nyo na. Kuha nyo na. Okay, nakita nyo dito sa kuwan. Andito sa tawag nito. Andito sa classroom. Week 10, activity 1. Okay? Ito yan. Okay? Isang question lang naman yan. May choices pa. Okay? 5 minutes. I give you 5 minutes. Sir Robert? Enjoy? Tuloy na natin, okay? Nakuha yata ni Robert yung sagot.